Hello everybody, I'm Scotty. Welcome back to Scotty's Clock World. This is a very handy tool to have on your bench when you are reassembling clock movements. Usually, using a pair of narrow point tweezers is how we move pivots into their correct bushings between the plates. But sometimes this is not enough. The pivot may be hard to get at with other wheels in the way, or the pivot may be down deep between the plates and hard to reach. This is where this easy to make tool comes to the rescue. Because you're not gripping the pivot with tweezers, but actually pushing or pulling it with this new pivot tool, you have more control over the situation. Always remember to loosen off the nuts holding the plates together before you start to move pivots around. Never force a pivot around in between the plates. If it is hard to move, loosen the plates off. Either of these two things make it quite likely you will snap off a pivot. Then you have some serious work to do to repair the damage. Replacement parts for 100-year-old mechanical clocks are not easy to find. That having been said, this is how you make this handy pivot tool. A pair of broad point tweezers is best to use, like these ones here, although narrow point tweezers can also be used, like these ones here, but you need to cut further down towards the handle to get sufficient width for the 2mm cutout in the end. Cut the tweezers into two parts, about 12mm or half an inch up from the end. Use a hacksaw or a grinding wheel. Then use a file to remove any burrs and smooth off the cut. Draw filing is the most efficient way to remove metal from a file, not rasping it backwards and forwards. Cut or grind down the other end of the tweezer so that it's flat, then remove any burrs by draw filing. Then, using a small rat tail file or a triangular file, make a 2mm cutout in the narrow end here. Using the same file, cut a wider 3mm cutout in the side of the tweezer, about 12mm or half an inch from the tip here. Check to make sure all burrs and rough points have been removed, and the tool is now ready to use. This clip is an example of movement wheels in the time train and the strike train, spinning freely after the plates were rebushed where necessary. All the pivots were repositioned into their bushings using our newly made pivot tool. Today we're going to put some of the pivot bushing theory from lesson 10 into practice. This is a perfect example of why it's an idea to take photos or make jottings and drawings of your clock movements as you're taking them apart, while you know exactly where they go. This lot here is spinning quite freely. Looking pretty good. Look down from the top. We can see they're all spinning nicely. There's only one problem. They've been put in upside down. Remember our piece of paper that we drew the orientations of the wheel on, so we can have a look and see. T1 has the wheel at the top and the pinion on the bottom. If we look there, the wheel is on the bottom, the lantern pinion's on the top, and so it continues all the way up the train. So even though that appears to be in pretty good shape and it's working nicely, in actual fact it's upside down. Right, I'll remove that and then we'll start again. Right, we're ready to start testing the wheels now. We'll take out T1, put it in the back plate, turn it sideways, move it around, and just check that's just within the 5 degrees angle. Put it in the top plate, check it again, see how it fits on the top plate. That's way more than 5 degrees. So that bushing will have to be replaced. So this is how we remember which bushing has to be replaced. We put a little black dot on it with a marking pen. And because we're replacing the bushing in the top plate, we'll also replace the bushing in the bottom plate, which is that one there. If you're replacing one, it's a good idea to replace the other one at the same time. And this is why. We'll have a look at a bushing, which we should draw like that. And then we'll draw the other half of the bushing like so. Now, our pivot, when properly set up, will run like that. That's the arbor, that piece there. Supporting the pivot in the bush is a couple of molecules thickness of oil all the way around, so there's very little friction in that bushing pivot combination. Now we'll have a look at another one. We draw our bushing again. This time it's a worn out bushing, so we'll make it a bit wider. So there's our second bushing. This time, because it's much wider, the pivot will sit like that. That's our arbor down there. Now what we've got here, we've lost the lubrication that we had up here in our first example. We've lost that. We've got the arbor touching on that side of the bushing there, and very close to or touching on that side of the arbor there. So we have seriously increased the amount of friction in that pivot bushing combination. And friction is the biggest killer of clocks, whether it's dirty oil, pivots out of alignment. That increased friction in 2 or 3 bushings, pivot combinations, will go pretty close to stopping a clock. It'll certainly slow it down, that's for sure. So that's what we're looking for when we look at the 5% angle. Let's say that's our back plate. We have a bushing there. We have a pivot that goes through. Arbor up there. We've got a wheel there with the teeth on it. And this arbor should theoretically stand 90 degrees perpendicular to the base plate. However, we're allowed a 5-degree angle. I'll draw this down here again. There's our bushing. Our pivot comes in at a bit of an angle, and instead of being perpendicular like so, the arbor sits out there like so. And that angle there is greater than 5%. So when we see a situation like this, that relates to this drawing we had up here, where the increased friction on either end of the pivot, where it's running through the bushing. And that's the 5% maximum that you're allowed before you have to replace the bushing. So this guy here will have to be replaced for sure. We now know that we have to replace that bushing there and that bushing there. However, we'll put T1 into the back plate. We'll put the top plate on it, on top of it. Line up the posts. It's about right. Now, we'll put the pivot into the bushing, which is there. So you can see how very easily that wheel spins. And when you flick a wheel like that, if it's set up properly, it should run for 15 plus seconds before it stops. So what we're going to do now is we're going to look at that pivot there, see what we got. And as you can see, moving it sideways, there's a reasonable amount of movement in that. Turn it upside down. Look at the pivot in the back plate, that one there. A little bit of movement in there, not quite as much. You remember that the bushing in the back plate there, when we stood the wheel up in it, the arbor was marginally on the 5% line. When we stood it up in the top plate here, it was probably about 10%. That's why that pivot there is a lot sloppier than the one in the back plate. All right, we'll take that out. In relation to setting your wheels up properly, if you haven't got this copy or photos or whatever, the best thing to do is to put the mainspring on, settle it down, put the arbor, it's better, into the back plate, and you know that that's exactly where that goes. When you take up T1, it's obvious it has to go in that orientation. It can't possibly go like that. So you know that T1 is set up correctly, because the teeth on this wheel are driving the trundles in this lantern pinion down here. That saves you setting the movement upside down like we had it earlier on. All right, back to our second wheel, T2, which goes there. Top plate on once again. Align the posts. Flip the movement over on its side. Using our trusty new pivot tool once again. We'll align this pivot into the bush up here. There we go. Spin the wheel. It's spinning quite freely. Right, now we need to check the pivots and the bushes. That one there. I'll move it backwards and forwards, left and right. No, there's very little movement on that. That's good. Turn the movement over. We're looking at that pivot there this time and moving it backwards and forwards. No, that's pretty good. So that arbor should be within the 5 degrees. Yep, that's all right. Put that back, take T3 out. That's where it goes there. The back plate, top plate on once again. Align the posts. Get the bushing, put the pivot into the bush. Spins nice and freely. We're looking at that pivot there now. Move it backwards and forwards. Oh, virtually no movement, that's good. The back plate, that pivot there. Move the wheel backwards and forwards. No, that's great. Alright, now T4, which fits up inside here. And that's got him. Bit of manipulation happening, but we got it. Okay, top plate on, line the posts again. We'll start off by moving this pivot over, because we've got to get the pivot into that bush there yet. So I'll lift that up so the pivot's in there. Then using our pivot tool, separate the plates a tiny little bit. Now bring the pivot back. Whoop, almost too far. Back to there. That's got him. Now we'll check that pivot there. I'll move the wheel backwards and forwards. There is actually a bit of movement in that. We'll check that one there. No, that looks alright. Right, well, we'll have to check this for our 5 degrees. Put that aside. Put that pivot back into the bush. Set it up. And as you can see, way more than 5 degrees. So we'll take that out. We'll put a mark on the plate there so we know we've got to do that bushing, and then pop that on there, see what the other bushing is. That one there, we'll put a mark on that. Once again, if we're doing one, we'll do them both so that they can align properly. Now the next thing we do is we put all the wheels into the train. Not only do we check them one at a time, we check them all together to make sure they're working in unison. Put our escape wheel back in again. Right, goes down there. Top plate on. I'll put a nut on that post there to hold that, because we've got a few wheels in there at the moment. They're all going to move around a bit. Alright, that's got that. Now, because in this type of movement, the escape wheel has a very long arbor on it, you quite often get caught up, and if you put the other wheels into their correct bushes, you're not going to be able to get the escape wheel done. So we'll get that done first. Lift the plate up a little bit. That's got him. And then as usual, start at the bottom of the train and work up. T1 just clicked in, you heard it. T2, now T3. And it looks as though the escape wheel's popped out. That looks about right. We'll just check that. There we go, that's got him. Now, tighten that nut up. We'll put one up at the top so nothing moves around on us. Okay, they don't need to be tightened down, just sufficient to hold it. And then we can start spinning our movement and see how it spins. Alright, so we've got 4 bushings we've got to replace there. The 2 on the first wheel, they're shaking away there, and the 2 on the escape wheel. And that's how you check your pivots, your bushes, to see what needs to be replaced. I'll have to replace those bushes, those 4 bushes, before we get on to the next step of putting it back together. But before I do that, I'll put the strike train in. I'll repeat what I've done up there through those, check and see if there's any other bushings that need to be done. If so, I'll get them all done. and then we'll be ready to start putting the movement back together again. Take them out, put them in our little foam block. A very handy little tool to have. Foam block, I've just got a little bit of felt on it with some holes punched into it, so you can put wheels from the movement in the correct orientation, and they can always be checked by looking at this diagram that we drew in, I think it was the second lesson before we started taking the movement to pieces.